Welcome to Parker. Let's talk electrification and the special requirements for thermal management. So my name, Andreas Lenowski. I am working close to 40 years in the business. I'm starting from hydraulic components to systems and commissioning. I joined Parker 2008 and now I have the job to make market and product development in the full life cycle management, typically or especially in the moment for electrification, hydrogen, and power generation. Let me look through the agenda. So we have the special requirements for thermal management in the electrification. It started with the unmet needs, the challenges in the components, the challenges in the systems, and maybe option to meet all these requirements. Let me look to the unmet needs. What are the challenges on the way to a better future with clean and environmentally friendly technology in the areas of electric mobility or electric storage systems, or maybe hydrogen production? Everything started with energy source. Every problem comes to space, power density, and efficiency. The reason is absolute every energy conversion process generates heat or requires heat. The challenge is to make this energy saving and reliable in use. When we look for space, maybe there's the existing chassis, the platform, there's a lack of space. There is a kind of electricity, hydrogen fuel cells, but everything needs cooling. This is an extra technology what's joined again the limited space. Then we look for power density. The system is in very narrow temperature range. So that's mean when we cool a diesel engine, there's a big tolerance. When you cool an electric motor, an inverter, a charger, a generator, a fuel cell, the tolerances are very small. Then we have the efficiency. And maybe we can talk a long time about efficiency, but what is the end? The battery size, and that's mean electrical power consumption as low as possible. And why? When we look to the density of diesel, we have close to 9 kilowatt hours per liter. When we look to lithium-ion batteries, we have 0.4 kilowatt hours per liter. That shows the difference between our existing machine and the new one. And then we come to this question, robustness. And we have all the climate zones where have to be operate our equipment. And then we come to the sound level. When we go electrifying our machines, then we have maybe most problem with the fan drive and the sound coming from the cooling. And when we go in urban areas, the noise level need to be minimized. Otherwise, the only crying part, it's thermal management or the cooler for it. And we heard from the other speakers, there's a lot of new technology. There's a lot of things what come up new. And for us, it's need to be simple, it's need to be easy, but the coordination with all other functions have to be in the system perfectly harmonized. Then we look for the challenges in the components. So what's fitted into the application in terms of space and performances? How do the individual components interact between? Where and how do I find the data? How accurate are the data? Where I can find the connection systems, what fulfill the requirements for temperature, pending radius, material flow, conductivity. And all this have to be harmonized, robust, and it have to be available. And then the next question is this accordingly to the power density I need, to the efficiency I need, how many losses I have. And that's why only when all components fulfill the requirements in all areas does this lead to a well-functioning and efficient system. Let me go deeper in the heat exchanger and fan drive challenges. You have a square size space, and maybe this is from the past fixed, and you need to be variable. Yes, that's what we challenged every time from our customer in projects. The square size need to be adjustable. We do it. We have a catalog product, but we have a modular system where we can help. The same question is, how deep is the complete system? Can I do it with a flat? Can I do it with a cube? How can I meet all the requirements? Parker decided to go to two options, one flat, one deep. And then next question, all the restriction in my very narrow area, how can I handle this? So we decided to go with different fan solution and different motor solutions so that we can go on high flow, high pressure. So we have the fan technology to meet exactly these challenges. Next part is, how can we bring the heat out of the coolant? So there's a lot of density in the motors. We heard it. It's very powerful. It's very efficient, but it's need a very precise cooling. So that means we need a high cooling capacity, and we need to select all the parts together that we bring the heat out. And this is what we did. We optimized our heat exchanger and make the turbolator so efficient that we have not all this problem with the space. Next part is clocking. So when I do everything very small together, how I handle the clocking. So important is that you define the fins very precise with a good material, with a good surface, what's avoid the clocking. And the other thing is, we can reverse spin our fan drives so that we can use a part to blow out the dust or the dust with humidity in the time where we have time to blow the parts out. The other point is different voltage ranges. I have a vehicle what started with 12 volt. I have a vehicle what I need 24. I like to do directly from the battery. So our modular system can support you with the different voltage range from 12 volt up to 850 volt. Then the next question, what is with the cleanliness level? What is with the conductivity level? A lot of motor supplier tell you, oh, low conductivity. Fuel cell supplier tell you 5 microsiemens or less. So all this we have in our modular system included so that we have a flashing, we control it, we do all this extra mile to give you a fast available product, especially for fuel cell on the vehicle or fuel cell in containers. So then we look here to the two design possibilities. We have the cube design, what's reduce the square size, but increase the deepness. The airflow resistance to installation space, it's quite high pressure possible and a high airflow. This is the powerfulest solution we have in place with the GVM motor as a fan drive air cooled, what's drive a lot of airflow in a high pressure. The cooling capacity with our heat exchanger is quite very high, the clocking about we can spin the fan reversible. We have the finished fins are for this perfect designed. Power supply voltage from low power to high power. The standard we have, it's from 500 to 800. Everything else need to be designed for you. Then we go to the next challenge, maybe multi-fluids. That means you have the fluid temperature, it's different between inverters, motors, chargers, hydraulic oil. Anything else? So we have the technology that we can build in one single heat exchanger, different chambers, and these different chambers give you the opportunity to have different circle for your cooling system. Then we go to the flat design. The flat design have increased the square size, reduce the deepness, have a very high airflow and pressure, not so high like the cube, but good enough in most of the application. Cooling capacity with the new heat exchanger is quite good. The same, all the fans are built to make a reverse spinning to clean the heat exchanger. What we provide here, it's a 12-volt solution, a 24-volt solution, and an 850-volt solution. And all this have an integrated inverter so that you can use this directly with a PWM signal. The next is the same multi-fluids. Available on the catalog on the website, a flat design with two chambers, maybe one for cooling water glycol, one for cooling hydraulic oil, or one for cooling A and B. The next option we listened to our customer was to swing up the fan house and the motor and the fan to clean the heat exchanger. This is an option with a guiding pin, so that's when you swing it back, the thing is very fixed in the center. The shakes and vibration doesn't destroy this. It is fixed with screws, so very reliable, very robust. And then we heard a lot of, we need more cooling pressure. We need a pump what can do this. So we go to a high performance water glycol pump. That means we look that the flow rate is high enough to combine 2 GVMs, 2 GVIs or more, maybe combine it with other cooling need, but have enough pressure to go all over restriction we have in the system. So when you like to go in serial, first in inverter, then in the motor, back to the cooler, the pressure increase. So this pump can handle it. Important, integrated inverter, controlled with a PWM signal, certificate it's CE and E marked to drive it on the road, power supply 12 and 24 volt DC. Let we talk about challenges on systems. So we have maybe on different areas on your vehicle, this is only a sample, like a truck with a crane. So the crane have the hydraulic on the back. You cannot use the cooling and thermal management from the truck. So you can place there a complete EPTO solution with the cooler complete as a box. We see it here in the top. Or you selected the cooler, the inverter, and the motor pump combination for yourself and place it anywhere. And you need a thermal management for your oil. So all this you see, it's available and we understand how it's works. And we can support you from the small piece of the bill of material up to the big piece. What we did to help you on systems, and we understand on the truck and other systems, there are really no space. So we're looking for a slim system, what's help you directly to go between the wheels or go in a very small space. So we go here with the first catalog product, what is a system with a tank, the ports for sensors, bleeding, connectors, a fan drive, RPM controlled with a PWM signal, a tank with ports for a level indicator, a gauge to see the level, have a transparent hose to see the air bubbles, maybe not. So, and a space that you can put a pump anywhere else. Or you like to have a direct system with a pump assembled. So then you have this heavy bracket, the pump assembled on the bracket. You have everything else there then too for high pressure, high flow, or when you have a single GVM, GVI, or other motors, other inverters, we built a slim system. Why the slim system is then available in 12 volt and 24 volt, so that you can go to vehicles with a lower power and have the same complete system available. And when you have the cooler as a single part for oil, or the cooler as a part where you place the tank everywhere else or the pump everywhere else, so the slim cooler, it's as a single cooler available. And again, it is very slim. It's only 282 millimeters. Okay, what help you to meet all these hundreds of parts in your bill of material? What we did is we put everything on the landing page so that you have all the parts on one single point in information, in product, article number available. And we built a sizing software what's help you to size the cooler, and you can size the single cooler, or you can size this in a serial or parallel application. So that's what we like to do for you, that you have very good self-service elements, or you come to us and we like to help you, or our integrator like to help you. And this included the filters, the connectors, the hoses, the sensors, the sealing, and maybe very detailed, the filler in your electric components. And of course, the controls. So we can help you with a simple software on the ICANN to drive our GVM, GVI, cooling system, or with the cooler QDC 006, whatever. We have a simple software for you in this kind of controller available. And we built for you a kind of fit into, so you can use this cooler, and the bleeding port fit into the port, the sensor fit therein. All the parts can be controlled by the ICANN. I think that's like to give you a one-stop shop and make it a little bit more easier for you to build a thermal management what is harmonized, where the components work perfectly together. There's no issue with temperature, corrosion, anything else. So that's maybe help you a little bit to come on your journey with the support from us, maybe faster and more accurate. So that was from my side. When you have questions, I'm really happy to support you. And then I will say, any question are welcome. Where can we get this tool? That's on the landing page from Parker. So in the presentation, there is a link, or we can send out from our sales company to you the link where you find all these landing page parts, and you find the sizing software, everything on one single point. Thank you. You see my contact data, so be free to contact me when you need more information or go to your sales company or your contact in Parker. And we like to support you and we like to listen to you. When you find anything we need more, tell me. Thank you very much.